Okay, so in this problem, we're going to be solving, or in this video, we're going to be solving this problem, number 4, from your problem set for periods 5 and 2. So Daniel wants to make a 15-liter of a 19%, sorry, that doesn't make very much sense, 15-liter 19% acid solution by mixing together a 55% acid solution and a 10% acid solution. How much of each solution must he use? So take a moment and identify, what are you finding in this problem? What is this problem asking you to do? And hopefully you answered that, or hopefully you figured out by now that you need to find how much of a 55% acid solution you need and how much of a 10% acid solution you need. So in the end, your answer should be two different numbers. So some amount in liters of solution A and some amount in liters of solution B. That's what your answer should look like in the end. Right below this, you're going to find, or you're going to identify, what do you know? What do you know? Well, you know that in the end, so at the end, you've got 15 liters of a 19% acid solution. 15 liters of a 19% acid solution. You also know that you've got two different solutions and you're mixing them together. So I'm mixing, we'll label it A amount of a 55% solution and B amount of a 10% solution. Okay. So now I want you to think, what can I try? What types of problems could I set up to solve this, or what types of equations could I set up to solve this? Well, if I draw a picture to go along with this, similar to the last one, so I'm taking some amount, I'll label it A, of a 55% solution, and I'm mixing that with some amount of solution B, which is a 10% acid solution, so that in the end I've got 15 liters of a 19% acid solution. So that's one equation that I could set up, and it's going to be just like the last problem we did. So I'm going to convert my percentages to decimals. So I've got 0.55 times solution A plus 0.1 times solution B equals 0.19 times 15. But take a moment and think, can I solve this problem just like it is? And if yes, how can I solve it? If no, why not? So I've got two different variables in this equation. Because I have two different variables, I actually cannot solve this just like it is. So I've got to kind of think outside of the box. Since I've got two variables, that means that I need a second equation in order to solve this problem. So what is a second equation that I can try? Well, I know that in the end, I want 15 total liters. But what I don't know is how many liters of solution A, which is what A represents, I'm adding or mixing with how many solutions or how many liters of solution B. But I do know that these two amounts, once I mix them and add them together, should equal 15 liters. So now I've got a system of equations. In order to solve this system of equations, hopefully you remember that in order to do that, I've got to get one of the variables by itself. This second equation is going to be a lot easier to get one of my variables by itself. I could easily solve this equation for A by subtracting B from both sides. So what I end up with, A equals 15 minus B. Now I should be able to substitute all of what A equals into this top equation. Go ahead and do that. You should pause your video. I'm going to post the solution in just one moment, so you want to be able to work this through on your own. When I solved this system of equations, so I plugged in 15 minus b in for A, so I get 0.55 times 15 minus b plus 0.1b equals 15 times 0.19. Then I'm going to distribute this in and multiply these two terms together, so I get 8.25 minus 0.55b plus 0.1b equals 2.85. Then I'm going to combine my like terms over on this side, so I've got 8.25 minus 0.45b equals 2.85. Solving for b, I'm going to subtract 8.25 from both sides. So I get negative 0.45b equals negative 5.4. Divide by 0.45 on both sides, I get b equals 12, and I'm going to add liters to this. Once I get to this step, have I answered my question? No. So in the end, my answer needed to look like some amount of liters for solution A and some amount of liters for solution B. So far, I've got the sum amount of liters for solution B. I've got to figure out how much of solution A I need to mix in. So in order to do that, I know that solution A is equal to 15 minus however much solution B is. So I'm taking A equals 15 minus 12. 15 minus 12, A is going to equal 3 liters. So now at this point, I've got 3 liters of the 55% acid solution. So that was solution A, and 12 liters, of the 10% acid solution. If you ask yourself, does this answer make sense? Well, it definitely both adds up to 15 liters, which is what it needed to be. 12 plus 3 I know is 15. If I'm trying to get to a 19% acid solution, I'm going to zoom out just a little. If I'm trying to get to 19%, 55% is a lot larger than 19%, so I know I'm going to need less of this, because 10% is a lot closer to 19%, so I'm going to have a little bit more of 10% to bring it down. So I should have more of solution B than I do of solution A, which my answer reflects. So I've got less of my 55% acid solution, more of my 10% acid solution. And that's the problem.